just have to put those numbers in. Okay, so here we go. Open up Desmos. Make a table. And then come back here. And we're going to copy and paste just this right here on the left. Okay, so not the whole thing. Control C. Back to Desmos. Where it says Y1, get rid of Y1 and paste. But we can see there's a problem. Change R into X1, because I got an X1 here. So whatever variable's over here has to match what's in the first column. So you literally just backspace on the R, type in X, still doesn't like it until you put that 1. This always has to match that. So far, so good. Okay. And then Desmos is fairly sophisticated. Once you put in the first couple numbers, so I put in my 1. Let's see if this makes sense. So it's 452 divided by 1 squared times pi. Well, 452 divided by 3-ish is about 150. Okay. So far, so good. Next line down. I'm going to put in 2. 2 times 2 is 4, and 4 times pi is going to be about 12-ish, more like 15-ish, because I'm going to have 4 times 3.14. So 52 divided by 1314 is about 35. Now watch the magic of Desmos. Desmos understands patterns. How far is it from 1 to 2? 1. Watch what happens. There's 3. There's 4. There's 5 and 6 and 7 and 8 and 9 and 10. Okay? So you don't have to type the numbers in. Okay? You do it. Just type it in. Open up Desmos. You don't need Canvas for this quick. Put in 452 divided by 5. All right. So we're back here. All you're going to do is copy the numbers, and let's do it to the nearest 10. Okay? So take the numbers from the table in Desmos, put it in the Canvas. Okay? So take a couple minutes to do that. And then it says, after you do that, what do you notice about the graph? Just take a few moments to do that. All right, so your table is now complete. You notice the numbers are getting smaller. Let's take a look at the graphs. Let's modify our window just a tad. So let's pull it down and to the left, so it only shows positives. And if we want to see the first number, we need to go up to 145-ish. So it's almost like a cliff. It drops off precipitously and then kind of flattens out. Will it ever hit 0? Why not? Because I'm dividing positives by positives. Can I ever divide a number that's not 0 and get 0? Okay, so I keep going on forever. I'm going to get something round and flat, like I had them last night for dinner, because I'm a rebel. Nice. What do you normally eat for breakfast that's large and round? Pancake, okay? So this is like your pancake. Like at this point, it's less of a pancake and more one of the French fancy pancakes. What are the French fancy ones? Crepes, because they don't have any baking soda. They don't rise at all. That's why they're real flat. Okay, so basically a flat cylinder, almost paper thin, if you will. Okay. So what do we notice? It goes down really fast and gets real close to, but never touches 0. Okay. Okay. Y values. Small, quickly, and use a fancy term, taper off. We'll use a different term, a more mathematical term tomorrow, and get really close to 0. So taper, a taper specifically, if you've ever seen a candle. Okay, come on, let's just take a look. So they're taper monkeys, that's a place. But we're not talking about that. So tape, not tapier. Taper. Like a fade. Okay, that's what a taper is. So a taper versus a fade. Okay, but if we talk about something like a candle, so a tapered candle, at the top part of the candle is actually called a taper, where it gets a little smaller and smaller and smaller until it just gets to the wick. So that's what it means by kind of taper. Okay. All right. Calculating surface area. So we're back to our cylinder, but this time instead of talking about the stuff that goes inside, it's how you make the cylinder in the first place. So even though you can't see them because they're not here, most cylinders have a what and a what? Top and a bottom, and they are circles. What's the formula for every circle? Don't say it, just type it. So we have the top and the bottom, and then we have the side. And the side is really just a what? It's just a rectangle that we turn into a circle. Okay? So take a moment. We have three things we need to add. The top, the bottom, and the side. I'd be really impressed if somebody can come up with the surface area formula. Okay. Three things. Two of them you can combine. So we really only have two things in the formula. So take a minute, see if you can come up with the surface area for the formula. The formula for the surface area. Here we go. So Tej, we have a top and a bottom in the circle, so that's 2 pi r squared. So start with that. So V equals 2 pi r squared. I'm going to start over here. Okay, volume. I'm sorry, not V, S. Capital S for surface area equals, thank you, 2 pi r squared, because we've got a circle on the top and a circle on the bottom. Okay, so that is 2/3 of our issue. Then Tej figured out. How did you figure out this?
Because it has a height.
Height, that's H.
And then I don't know, I just do V to the R, and it's two of them, folded in half front back, so it's just 2 pi R units.
Where's the 2 pi r coming from?
He probably just looked it up.
Not area. Not area.
Two faces.
What's it called when you go around the circle? And what's the formula for circumference of a circle?
2 pi r.
2 pi r. Okay? So,
He looked it up.
plus 2 pi r h. Okay? A little more complicated than the volume because we've got to have to add it in there. If you wanted to get fancy, you can use my favorite math F word, factor. Okay? We're not going to do that. We're going to leave that alone. Okay? All right. And they're specifically telling us that the volume is 452. Did we have a formula for volume? We did, didn't we? Okay. So let's start with that. We had volume was equal to, let's just use the formula. Sorry. My bad. So V equals pi r squared h. R squared h. Okay? All right. Which part does this look closer to? The 2 pi r squared or the 2 pi r h? 2 pi r h. It's pretty close. It's got a lot of the same components, but not quite the same. Okay? So what we need to do is make this, or make this kind of like this. So what do we have to do to the pi r squared h to get 2 pi r h? Take a minute so you can figure that part out. So one more time. Here's the question. What do I need to do to the pi r squared h to make it look like 2 pi r h?
Add a 2 on it.
We're not adding. Okay. So first of all, we can see this has a 2 in it here. So we need to put a 2 here. But whatever we do to one side,
Yeah,
do the other. Okay. My issue is I'm trying to turn 2 pi r squared h into 2 pi r h. I only need to do one more itty bitty thing. Somebody said something about dividing. What are you going to divide by? Nope. If we divide by 2, we just lost the 2 we multiplied by. We want to change r squared into r. One more time. Divide by r. So we come here, divide by r. So I come over here and divide by r. So why am I doing this? Because I already know what the volume is. Okay, so since I know what my volume is, I can rewrite this. So I'm using this idea. I'm going to take different color, this right here, and put it in right there. Okay? So we're going to rewrite it. Way. So S equals 2 pi r squared plus 2v divided by r. Okay? So now h is out of the picture, and that's what we're going to end up solving for. Okay? I'm sorry, h is out of the picture because we already have h. So we're going to do the same thing we did before. So we're going to use our radius and our height from up here. Oh, look, we found all those heights. So let's copy this. But see, that number is really big. Which one's probably going to be easier to start with? 2 or 3? So let's start with 3. So we're going to use, we don't have to do all of them. Let's say 3 down to, just 3 down to 8. Okay? So fill in the table. You're going to retype those numbers. So for the radius and the height, down here. Okay? So starting at 3, we got 3, 4, 45, 5, 6, 7, 8. And then go back up here. Tap, 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 tap. Come back here. Okay. I don't know. Can we copy and paste? We can try. So I have a feeling it's not going to work too well, but we can give it a shot. Oh, you know what? Let's make a new one. And paste. Hey, look at that. Almost worked pretty good. Enter. There we go. Okay. So now we have the radius. Do we really need the height to calculate surface area? Because we got this. So you're going to use the numbers on the left. And in place of v, what we're going to put in?
Oh.
452. Okay. So let's rewrite this. Let's do a copy and paste action. A little Control A, Control C. Oopsies. Control V. And let's just change the V up here to times 452. Okay? And what should we do? Put it into Desmos. Okay? So let's make a new table. Control C. Go to Desmos. I don't want to delete these numbers, but I don't want to see them, so let's just turn them off. Make a new table. What were we starting with? Not 1, not 2, but 3, 4, and then I'll remember the pattern. Okay. Now what are we going to do for Y2? Paste. Okay. But we have to do a little something after we paste, right? Change all the R's into Not x1s this time. Okay, whatever this number is. So if it's a 3, it's x3. If it's 4, it's x4. In this case, it's 2. So change both r's, x2. Look at that. It's a lot of numbers, but it looks a little bizarre. So let's change our window so we can kind of see these. So we need to go from like 350 to 550 on my y's. Just so I can see those numbers. 350. It's kind of interesting. It dips down and then goes up. Okay? So, but it's not exponential because it's only exponential if the variable's in the exponent.
Geometric.
Okay, this is your new type of function. This is called a rational function. Whenever we divide by a variable, that is no longer a polynomial. And you can kind of tell because if we connect this, it comes down and goes back up, but it goes up kind of in a different way. Doesn't go straight up, not like a polynomial. It's called a rational function. That's its name. It's not. It hasn't have any other name. Okay. All right. So, what you notice about the graph? Goes down and then goes back up. Okay. Because what happens as my x values get bigger? So we can go a little bit bigger. We can go 9. We can go 10 if we want. Oopsies. Or kind of go crazy. Put 100 in there. So are they ever going to get smaller again? Why not? What's happening with my squared? I'm taking a big number and squaring it. That makes it huge. And then I'm taking 2 times 452, which is 904, and dividing it by that same number. That's not going to be that much of a difference. So if I change this to even bigger numbers, like 1,000, whoa, now you're talking in the millions. So my surface area, theoretically, okay, can be infinite in size. Why? Because if I could theoretically make my radius as big as I wanted to, shouldn't my surface area be even bigger and bigger and bigger? So it dips down and kind of, you have a minimum right here. So when it's a radius of 4, okay, you have a relatively little amount of surface area, 326. But once you go up to 5, now it's going to bounce up and get really big really quickly. All right. So write the equation for s as a function. I think we did that already. We make it. I know. And I told you today's building blocks. Tomorrow, I promise, the actual functions will be a lot simpler. Promise. Okay? What's 2 times 452? 904. So let's just simplify this. Control A, Control C. Equation. And let's just simplify it. So in place of, come on now. Cammy, I really want to give you the finger right now, but I'm not gonna. There we go. Paste. Up. 904. That's it. So you don't need to know the height. If you know the volume, it's fixed. Okay, because the volume is going to fix that height. Okay, well, let me rephrase it. It's not going to fix the height. You can rewrite everything in terms of R. What's easier, 1 variable or 2? So, are you ready for more? We don't want to do this one. Okay. So let's just look at the summary. So here's our summary formula. This is for any cylinder. They picked a volume of 330. How'd they get 660? Multiplied it by 2. So regardless of what your volume is, when you're finding the surface area, once you know the volume, you just take the formula, take the little part on the top, multiply it by 2, and divide by R. And that's all you got to do. Okay? That's it. Okay. So your graph's always going to look like this. It's going to start big. It's going to dip down. It's going to bottom out at some point. And then it's going to go up at an angle. And then I could actually draw a line if I wanted to. And it's kind of interesting. We're going to talk about this in a couple weeks. This graph will get really close, but never touch this line. Okay, and I'll talk about what that line means tomorrow. And that's about it. So anytime I am dividing by a variable, that is called a rational function. That's the new stuff for today. I know this particular equation was a little complicated to deal with. I promise you the Western ones are going to be relatively easy. All right, so cool down. Talk about it in like 3 or 4 minutes, and then the rest of the time we'll work on practice. Go for it.